I just went on a rant about something I hate, so it seems like a perfect time to make an algebra video. This is Unit 6, Lesson 3, Relative Frequencies. So there are different types of relative frequencies. There's a joint relative frequency, which represents the frequency for one particular category. There's a marginal relative frequency, which represents the frequency of all the joint relative frequencies in one row or column. And there's a conditional relative frequency, and that's the process of finding the ratio of frequency in a particular category in the total number of data points in a particular category. That's what we're going to talk about today. These three definitions should be in your notes. Here's a check-in. Which type of relative frequency, joint or marginal, represents the frequency for one particular category of data? You should have this in your notes. It's a joint relative frequency. Types of relative frequency. So a joint relative frequency is specific, and a marginal relative frequency is broad. Okay. Joint frequency tables, each entry except the total sections, are considered joint frequency values. Joint frequency represents the joining of two categories of data. For example, here it's combining football players and sports drinks, so it's a joint frequency. Okay. Joint relative frequency is the ratio or percentage of a joint frequency within a specific category in a set of data. So to find a joint relative frequency, you need a joint frequency and the total number of entries in the survey. So you would take one of these 4 pieces of information here and you would divide it by the total number. So it would be like 16 football players also prefer water. So it would be 16 divided by 140, which will give you a percentage for this cell. It will make sense as we go along. Here's example number 1. Calculate the joint frequency for each entry in the two-way frequency table and interpret the results. Okay, so they want us to find the joint frequency, for each of these entries, okay, and interpret the results. So for each joint relative frequency, you will divide the category by the grand total of 140 to determine the ratio or percentage of each category. Okay, so the way that you do that is, I'm going to take 57 divided by 140, which is going to give me 41%. Okay, 29 divided by 140 is 21%. 16 divided by 140 is 11%. 38 divided by 140 is 27%. So once you calculate all joint relative frequencies, you can create a frequency table for the data by placing each joint relative frequency into their corresponding space. The values in the total row and column are calculated by finding the marginal joint frequency. Next, you will learn how to find that frequency. Okay, we're not quite there yet, so don't worry about the totals. This is just how to find the percentages for each cell in this table. All right. Calculating marginal joint frequency. To calculate marginal relative frequency, divide the total for a given category by the total number of entries in the survey. Use the total from the entire row or column. Okay, this will make sense. It's okay, don't stress. Here's a check-in. To calculate both joint and marginal relative frequencies, which are the two frequencies we were doing before this lesson, you must use the blank as a divisor. The grand total value, which is that number that's right here in the table. Okay. Here's example number 2. Calculate the marginal relative frequency values from the two-way frequency table, then interpret the results. Okay. So we already know that we had these percentages before. Okay. So now that you've calculated the remaining marginal relative frequency values, you can combine them with the joint relative frequency values to create a complete relative frequency table. Okay, so 41 plus 21 gives you 62%, 11 plus 27 gives you 38%, 41 plus 11 gives you 52%, 21 plus 27 gives you 48%. All right. A characteristic of all frequency tables is that the marginal relative frequencies always add up to 100%. 52 and 48 is 100, 62 and 38 is 100. Relative frequency tables provide a clear, organized way to find the percentage or frequency of any category of data that is needed. Okay, so when you're dealing with relative frequency tables, which we're dealing with today, you're getting percentages. So you're getting to look at, instead of just numbers like 273, 32, 1, 19, whatever, this gives you a clear look at the percentage of people that prefer like sports drinks 1 here, water 1 for soccer players. So if you're only going to get 1 drink for each of these people, you're better getting sports drinks for football players and water for soccer players, right? This just gives you a clear, easy way to look at it using percentages instead of the actual data numbers. Okay. Here's question number 1. This is your turn. You are trying to determine how many people went to the movies or a baseball game this past weekend and ordered popcorn. You have conducted a survey and organized the two-way frequency table, which is right here. Based on the data, what is the percentage of people who went to the baseball game and did not order popcorn? Okay. Pause it, figure it out, come back. So we're dealing with the people who went to the baseball game. So right here, and did not order popcorn. So we're dealing with this cell. Guess what? I did it wrong already because I'm a genius. Okay, so we're looking right here. This is, come on, give me my pen. This is the cell we're looking at. We want to know, we're looking at just the people who went to baseball games, okay, and did not order popcorn. So we're going to take 264 and we're dividing it by 353 because we're looking at just the baseball game. Okay, so let me get my calculator. 264 divided by 353 gives us 0.74787 blah, 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 blah. Okay, so we're going to go 0.748 and we're going to round it. Okay, so what that means is in a percentage, this is tens, hundreds, okay, so this is the percent and we want a whole number. So this is going to get rounded to 75. Now I'm confused because it says, whoops, it says 15% of people who went to the baseball game ordered popcorn. Okay, so this is 15% ordered popcorn, but it asked how many didn't order popcorn. So that would be, it says right here, did not order, and then it gives us the answer for how many people did order. Come on, book. So if we said 75%, yeah, that would be right. We were right. So it's actually 75%, but they're giving us a stupid answer because 75 plus 15 would give us 100. So I don't know why they're being stupid like that. I guess because I love math. Here's question number 2. Using the two-way frequency table, construct a relative frequency table. Okay, so this is all you. They want you to make a relative frequency table, which means it has percentages here. Pause it, figure it out, come back. Okay, so in order to fill in these 4 squares, you need to use this total. So 185 divided by 595 is going to give you 31%. So this one's going to be 31%. Okay, 89, come back calculator. 89 divided by 595 is going to give us 15%. It's 14.9. Okay, 57. Whoop. Come back. 57 divided by 595 is going to give us 10%. I'm rounding up. Okay. And 264 divided by 595 gives us 44%. Okay. Now, the way you can figure these, there's 2 ways. You can add these together and it's going to give you the percentages, or you can actually do the math. But I'm just going to add them together because that's easiest. So this is 46. This is 54. And look, if you add these together, that gives us 100, as it should, because we're dealing with percentages. Okay, 31 and 10 gives you 41. 15 and 44 gives us 9 and 5. 59 and 41 gives us 100. Okay, so 31, 15, 46. We did that. 10, 44, 54. Yep. 41, 59, 100. Okay, we got it all right. That's how you make that frequency table. Here is practice question number 1. This is at the end of your lesson, so you'll want to write your answer down so you can enter it when you go fill out your lesson, whatever. This table presents the season performances of elementary and middle school students between summer and winter. What is the joint relative frequency of elementary age students who prefer winter? Round to the nearest whole number. Pause it, figure it out, come back. Okay, so we're dealing with prefer winter, okay, and elementary age students. These are the two we're dealing with. So here's our cell, okay, and they want the joint relative frequency. The joint relative frequency is just one particular category, so your answer is right there. Your answer is just 84. You don't need to do any more math, okay. Here's practice question number 2. This table presents the total number of senior and junior drivers and non-drivers. Using data from the table, what is the marginal relative frequency for drivers? Round your answer to the nearest whole percent value. Pause it, figure it out, come back. Okay, so we want drivers, and we want the marginal relative frequency. Looking at my notes, that says for all frequencies in a row or column. So for drivers, it's right there, but they want our percentage value, okay? So what we're going to do is we're going to take 77 and divide it by our total, which is 119, okay? So we're going to go 77 divided by 119 gives us 0.647. So we're going to round to the nearest percent, right? So it's going to be 65%. That's your answer, okay? Here's quick check question number 1. I won't give you the answers to these because that's cheating, but I will tell you how to figure out your answer. This table shows whether 3rd and 4th graders have a pet or not. Use the relative frequency table to decide which of the following is a correct interpretation of the data. Okay, so the largest joint relative frequency is 4th graders with a pet. Largest joint relative frequency is a single cell. Okay, so they're saying for these 4, the largest one is 4th graders with a pet. It says more 4th graders responded than 3rd graders. That, we don't have the actual numbers, okay, of how many people responded. The smallest joint relative frequency is 3rd graders without a pet. So 3rd graders no pet, they're saying this is the smallest joint relative frequency. And most students in the sample have a pet. So they're saying most of the kids have a pet. Go ahead and figure out which one this is. Quick check question number 2. This two-way table shows the number of people who visited the library on weekdays and weekends for either pickup or browsing. Using marginal relative frequency, what interpretations can you make from the data in the two-way table? So marginal relative frequency deals with the whole row or the whole column. Okay, so we're dealing with these numbers out here. They're saying people only come to pick up reserved books during the week. The weekend is the most popular time to visit. The pickup service is not very popular at this library, or a high percentage of people pick up on the weekend. Okay, remember they shuffle these answers. Your answers will not be in the same order as mine. Okay, let's talk about conditional relative frequencies. This is our new type of relative frequencies. Okay, the percentage of all joint relative frequencies within a row or column. Example, the percentage of students who prefer flip-flops given that they prefer shorts. So you'd start with flip-flops, then you come over here to shorts, okay? Found by dividing the joint frequency of the desired category, so this thing, by the total for that category, okay? We're dealing with people who prefer flip-flops, so it would be 42 divided by 57, all right? To determine the percentage or conditional relative frequency of students who prefer flip-flops, this is number 1, given that they already prefer shorts, okay? Focus on the total for the shorts column. Oh, I guess we're going with this. Okay, so we're doing this for our total and this for our cell. The total number of students who prefer shorts is 79. This is the denominator of the conditional relative frequency since it is the whole being considered. So it would be 79 on the bottom and 42 on the top. 42 of these 79 students prefer flip-flops. This is the numerator of the conditional relative frequency since it is the part of the whole being considered. The conditional relative frequency of students who prefer flip-flops, given that they prefer shorts, is 42 divided by 79. As with other relative frequencies, round the decimal to 3 decimal places and the percentage to the nearest whole number. So if I grab my calculator and we go 42 divided by 79, we get 0.531. So our total is going to be 53%. Okay. The conditional relative frequency of students who prefer flip-flops, given that they also prefer shorts, is 53%. This outcome means that 79% of students in this survey who prefer shorts, 53% of them prefer flip-flops. Okay? So when we're doing this, the first thing they say, we're going to follow across, and then the second thing they say is going to give us our total. Okay? The second item in the list. Here's a check-in. How is calculating the conditional relative frequency, which is what we just did, different from calculating a joint or marginal relative frequency? How are they similar? To calculate a conditional relative frequency, use the total from a row or column as the denominator, and the frequency of the category of interest as the numerator. For joint or marginal frequency, use the total number of data points in the table as the denominator. So for conditional relative frequency, we're using one of these totals, okay? And for the other two, we're using the main total. All of these frequencies are calculated by using part of whole ratios. For joint or marginal frequencies, the whole all data points. For conditional relative frequencies, the whole is only the data points with the given conditions. So in your notes, under joint relative frequencies, we have the main total that we're using. For marginal relative frequencies, it's the main total and we're getting a percent. Okay. And for conditional relative frequencies, it's row or column total and we're getting a percent. Okay. You should put that in your notes so that it will help you later. Because remember, we have a unit test and it's going to be hard to tell all of these apart. Conditional relative frequency tables. You are constructing a conditional relative frequency table of students who have a footwear preference. This means you will use the total of those who prefer sneakers and the totals of those who prefer flip-flops. The total frequency of those who prefer sneakers is 85. You can see that right there. The total of those who prefer flip-flops is 57. These values will be the denominators in your calculations, okay? Because we're doing conditional relative frequencies. We're not using this total. We're using these ones. Determine the relative frequency of each of the joint frequencies using the appropriate denominator. So it wants us to figure out the frequencies here using our correct denominators, okay? Students who prefer pants, given that they prefer sneakers. So this one, it's already told us we're not using this one and we're not using these ones, okay? So we're going to go 48 divided by 85. Whoops, fat fingered it, is going to give us 0.564. So this is 56%. I'm not writing the percents because it's already messy, okay? This one is 37 divided by 85. 37 divided by 85. That's going to be 0.435. So that's going to be 44%. I can do the percent sign here. I have enough room. Okay. Let's do 15 divided by 57. 15 divided by 57 gives us 0.263. So this one's 26%. Okay. 42 divided by 57. 42 divided by 57 gives us 0.736. So this one is 74%. Okay. Let's continue on. Construct the conditional relative frequency table by recording the determined values appropriately in the table. So we have, oh, they did 57. Okay, 57 and 44 and 26 and 74, which is what we got. Okay, now on this one, we ended up with a total of 101%. And that's because they rounded this one up. Okay, so don't stress about that. That's okay. We don't have a total down here because we're using this over here, this column, as our totals, okay? We don't have them in both places on the conditional relative frequency tables. You only have totals on one side, okay? Let's see. Here's a check-in. Use the two-way frequency table to construct the conditional relative frequency table for students who have a preference for pants or shorts. Okay, conditional relative frequency table. Because we know we're dealing with pants and shorts, all of these are not being used. We're using just these. Okay, so pause it, figure it out, come back. To solve this, it's going to be 48 divided by 63 for this number, 15 divided by 63, okay? 37 by 79, 42 by 79, and you're going to end up with this, okay? Conditional relative frequency tables, you can tell which of the categorical variables in the conditional relative frequency table is the given condition because the sum of its joint relative frequencies is 100. So if you're over here and you're like, oh gosh, I don't know where my total column goes, if you add 76 and 47, you're not going to get 100% over here. And if you add 24 and 53, you're not going to get 100% over here. So this has to be where your total column goes. So if you're ever in doubt, just figure out where you're getting 100%. That's where your total column goes. Okay. Here's question number 1. This is your turn. Given that a person is an adult, okay, so we're dealing with adults, what is the conditional relative frequency that they prefer a beach vacation? Okay. Adults and beach vacation. Let's see if we can figure this out. Pause it, come back. Okay. Well, we know that we need to have one that goes all the way across, okay? This one doesn't. We don't have beach and adults lining up, so I'm guessing that our answer is going to be 30%. Let's see if it's correct. The given condition is that the person is an adult. Use table 1. Yay! Because it shows the sum of the adults row and the sum of the children row each equal 100. The conditional relative frequency that a person prefers a beach vacation given that they are an adult is 30%. In other words, 30% of adults prefer a beach vacation. Yay, yay, yay. Here's question number 2. This is your turn. Given that a person prefers a beach vacation, what is the conditional relative frequency that the person is an adult? So it's either here or here. Pause it, figure it out, come back. The given condition is that the person prefers a beach vacation. Use table 2 because it shows that the total of each location column is 100%. The conditional relative frequency that a person is an adult, given that they prefer a beach vacation, is 25%. In other words, of those preferring a beach vacation, 25% are adults. Here's question number 3. This is your turn. Given that a person prefers a mountain vacation, what is the conditional relative frequency that the person is a child? Okay. Pause it, figure it out, come back. The given condition is that the person prefers a mountain vacation. Use table 2 because it shows that the total of each location column is 100%. The conditional relative frequency that a person is a child, given that they prefer a mountain vacation, is 34%. In other words, of those that prefer a mountain vacation, 34% of them are children. Here's another check-in. Question 1 asks, given that a person is an adult, what is the conditional relative frequency that they prefer a beach vacation? Well, question 2 asks, given that a person prefers a beach vacation, what is the conditional relative frequency that the person is an adult? Why are the conditional relative frequencies of these two problems not the same, even though they involve the same variables? They both deal with beaches and adults. Why don't they have the same answer? The first problem uses the total number of adults as the denominator and the number of adults who prefer the beach as the numerator in the ratio to calculate the conditional relative frequency. So this is the first one. The second problem uses the total number of people who prefer the beach as the denominator and the total number of adults who prefer the beach as the numerator. Okay, so this one's using the adults as the main factor, and this one's using the beach as the main factor. While it is possible for two conditional relative frequency tables constructed from a data set to have the same values, this is rare and would occur when each conditional relative frequency is 50%. Question 1, your turn. Based on the data, which topping was more popular given the favorite flavor is chocolate? What is its conditional relative frequency? Pause it, figure it out, come back. Okay, well, the most popular one is obviously jelly beans. And to find its conditional relative frequency, you're going to take 125 divided by 190. 125 divided by 190 gives us 0.657, so it's going to be 66%. Ba-ching! Jelly beans with the conditional. Oh, I am so good. Question number 2. Construct a conditional relative frequency table given a preferred topping. Interpret the table. Okay, so we're dealing with the preferred toppings. These are our magic things. Pause it, figure it out, come back. Since we're doing it with these, we know that all this is gone. Okay, so 102 divided by 167, 65 by 167, 73 by 198, 125 by 198, and you're going to get, oh, did I not? There. And you're going to get that. Okay. Since the given condition is preferred toppings, use the totals of the toppings column in your calculations. Given a person prefers sprinkles, 61% will prefer vanilla, 39% prefer chocolate. Given they prefer jelly beans, 37% prefer vanilla, 63% prefer chocolate. I don't like jelly beans unless they're Jelly Bellies because I'm bougie. Here's question 3. Interpret the two-way table for students' drink and food preferences. Given the students that prefer soda, what is the conditional relative frequency that they like hot dogs? Round your answer to the nearest whole percentage. Now I'm a little confused on this one because before it was saying we should use this one as the denominator. But now it's telling us we should use this one. So pause it, figure it out, come back. The way I would solve this is I would do both ways and then see which one is going to give me 100% because that's going to give me my answer. So that's what we're going to do. We're going to do 20 divided by 61 because it taught us that little trick. Do you remember that? 20 divided by 61 gives us 33%. Okay, so this is 33. 41 divided by 61. 41 divided by 61 gives us 67. Hey, guess what? That's going to give us 100% right there. So it's going to be this way. So our answer's 33%. Doop-a-doop. Look at me. Okay, here's end of the lesson. Practice question 3. This two-way table presents a student's drink and food preferences. Given the students that prefer soda, what is the conditional relative frequency that they like hot dogs? Round your answer to the nearest whole percentage. Pause it, figure it out, come back. Okay, I'm going to grab my calculator. We're going to go 20 divided by 61. It's going to give us 0.327, so this is 33%. Now just to double check that I'm doing it right because I suck at math, I think this is the exact same one we just had. 41, 20, 60. It is, so the answer is 33%. Here's practice question number 4. This two-way table presents students' drink and food preferences. Use the two-way frequency table to complete the conditional frequency table for students who prefer hamburgers or hot dogs, given they prefer soda or water. Round each percentage to the nearest whole number. Pause it, figure it out, come back. So 41 divided by 61, which we already did, but I forgot, gives us 0.672. So this is 67%. And then hot dogs, which I forgot already, is 20 divided by 61, gives us 0.327. So this is 33. There you go. Problem solved. Here's quick check question number 3. At Fairmount Elementary School, 108 students were polled about their mode of transit to school and on the distance they live from school. Interpret the table to find the conditional relative frequency of students walking to school, given that they live more than 1 mile away. Okay, so you're going to take your 6, you're going to divide it by something, which you should know by now. Hint, it's none of these. And then you're going to get a percentage, which eliminates 2 of your answers, and you'll put it in down here. Okay, This is the last part of the lesson. We're going to talk about association. It occurs when two variables in a set of data relate to each other. For example, given the month and a location, you can probably predict whether it will be hot or cold. Association allows you to better interpret data and prepare for a given situation. So recognizing association from conditional relative frequency, you start with your table, and then you're going to interpret your table. On any day in July, there is a 5% chance of cold weather and a 95% chance of hot weather. On any day in January, there is an 83% chance of cold weather and a 17% chance of hot weather. Now we have to determine if there's an association. An association likely exists when there's a clear difference between the conditional relative frequencies of each categorical variable. The larger the difference, the stronger the association. The smaller the difference, the weaker it is. If there's little or no difference, an association is unlikely. There's a noticeable difference here between each set of percentages in this table, so there's likely a strong association between the month and the weather, which makes sense. Here's question number 1. This is all you. A survey was conducted to determine children's favorite fruits. The data was organized into the conditional relative frequency tables shown. Is an association between the variables likely? Interpret the data in the table. So pause it, figure it out, come back. Looking at these, you can see that the percentages are very close to each other. So it's likely there's not an association. 48% of girls and 54% of boys prefer apples. 52% of girls and 46% of boys prefer strawberries. So there's probably not an association between gender and which fruit they prefer, because it's pretty evenly split. Okay. Here's question number 2. This is the same information. Do the percentages reflect a likely association between the variables? The difference between the percentage of girls and boys who prefer apples or strawberries is small. Conclude that most likely there is no association between the variables. Here's example number 1. The table displays the results from a survey of favorite outdoor activities of people who can swim and of people who cannot swim. Does an association exist between the categorical variables? So the first thing we need to do is calculate the conditional relative frequencies for a favorite activity given that a person can or can't swim. We need percentages, okay? That makes it a lot easier to interpret this data, okay? So what you're going to do is like 237 divided by 320, 83 divided by 320, 46 divided by 253, okay? So we do that, we get our percentages, and we can see that the frequency table shows a noticeable difference between going to the beach and park given the ability to swim. If you can swim, you're much more likely to go to the beach. If you can't swim, you're much more likely to go to the park, okay? Which also makes sense, because the beach isn't very fun if you can't swim. Causation is a relationship between cause and effect, and it occurs when there is a consistent and predictable relationship between variables. For example, one event, such as a heavy rains, causes another event, such as flooded streets. An association does not automatically imply causation, okay? Sometimes there's causation, but not always. Here's question number 1. A conditional relative frequency table displays the data from a survey on hot dog topping preferences and whether a person last attended a movie or a baseball game. Interpret the table. So if we look at this, we can see that at the movies, people got chili most of the time, and at the baseball game, people got mustard most of the time, okay? And there's a pretty significant difference between these. These aren't like 50-50. It's like 70-30 and like 80-20, basically, okay? Whoops. So, yes, there is an association. Is an association between the variables likely? Yes, okay. There is a noticeable difference between the frequencies, a strong association. What are some possible reasons for a person's preference at the movies or at a baseball game? So there's a million different suggestions, but they said that like maybe, at the movies, people over here. Sorry, I couldn't find it. So maybe they ran out of mustard at one place, or maybe plain hot dogs were on sale, and so more people bought those. Or, there's lots of different reasons. Me personally, I wouldn't get a chili dog at the movies because I would be afraid of spilling chili all over myself in the dark, but I'm a slob. Does an association in a data set always indicate causation? No. Okay, your turn. Question number 1. Consider the table. It displays the conditional relative frequency data on the type of vehicle and amount of gas consumed on average. Does this data indicate association? Why or why not? Could this data indicate causation? Why or why not? Pause it, figure it out, come back. This data represents an association because it shows a significant difference in gas usage between SUVs and compact cars. SUVs use way more than cars. Cars use way less than SUVs. This data could indicate causation, although factors such as the location where a vehicle is driven or the driving style of the driver could explain why an SUV uses more gas. It is reasonable to conclude that an SUV typically consumes more gas than a compact car in most situations. So causation probably exists. Here's question 2. A group of people are surveyed and asked if they prefer reading or cooking on a rainy day. The data is organized into a two-way frequency table. Construct a conditional relative frequency table based on gender to determine whether an association between gender and preferred activity is likely. Pause it, figure it out, come back. It's said to do it based on gender, so this is all going to go away. Okay. You're going to take 132 divided by 377, all that jazz, and this is what you're going to end up with. There is a moderate difference in the conditional relative frequencies given the gender of the person. 35% of men surveyed prefer reading and 65% prefer cooking. 61% of women surveyed prefer reading and 39% prefer cooking. Okay, so yeah, there's a difference. It's not as big as some of the others we've seen, but yeah, there's probably an association. Here's practice question 5 at the end of your lesson. The table displays the conditional relative frequency, Angie just tripped, data from a study on whether individuals speak English and at least one other language. Does this data reveal a likely association between the variables, the conditional relative frequency variables? Oh, look, I already gave you the answer. Sorry. Psych. I guess you know how to do this one on your own. Yes, there's an association. You can see that because of the big gap between the percentages. Oh, no, I didn't answer it. So the conditional relative frequency of the variable indicates that an association is likely. I gave you the answer anyway, since the percentage of the variables are not relatively close to one another. She ripped her pants when she tripped. Here's quick check question number 4. I will not give you this answer. High school juniors were asked about how many hours a week they practice their musical instruments to prepare for a musical competition. The study included 68 participants, and its intent was to see if there was a difference between competition levels of 1 and 3 and levels 4 or higher. The results are summarized in the table. Which statement is a correct association that can be made based on the data provided? So it says if a student practices more than 5 hours, okay, so that's here, they are likely to be at a competition level of 1 through 3. That's the first one. There is an association between the competition level and the number of hours practiced. Okay, so that's saying that the level and the hours practiced, there's an association between that. All students are more likely to get a competition level of 4 or higher with less than 5 hours of practice. There is no association between the competition level and the number of hours practiced. Okay, good luck on that one. Quick check question number 5. At a local amusement park, parents were asked whether they were season pass holders and the ages of their children. The results of the survey are in the table. Which statement describes a correct association for the data? There is no association between the ages of the children and whether a parent is a season pass holder. The older the children, the more likely it is that a parent has a season pass. So if the kids are older, they're more likely to have a season pass. The majority of non-season pass holders have children under 18. Okay. Under 10, sorry, right there. There is an association between the ages of children and whether a parent is a season pass holder. And Canva actually does have some cute stuff. It's not all disturbing stuff like the poop in the sink.